Hello everyone. So in today's talk, we will discuss about the Kotlin's 1.4.20's impact in Android, and we will see what are the major changes that will impact the Android developers' day-to-day life if they want to use the Kotlin's latest features from their latest updates. So let's get started. So far we have a Kotlin Android extensions since the Kotlin released, I think since 2017. And we all are very happy because it makes our life very easier because they provide us a synthetic sugar, which provides us a way to accessing the views from our Android layouts like very easily without using the old way of using find view by IDs and then casting them to the relevant views like text views or image views. And also it provides us the parcelize annotations that helps us to easily passing a data between activities, and this annotation it manages the lot of boilerplate code for us under the hood. So these are the main features that we have like since 2017, but the synthetics it has a lot of issues that are later identified by many developers, and most of the time people try to avoid using the Kotlin synthetics, but sometimes when we don't have enough experience and we are kind of a new to Android development or Kotlin, we love to use synthetics, and later on we might found issues, and then at that point we try to reconsider our decisions that we made earlier. So what are the main drawbacks of the Kotlin synthetics? So there are three major issues that the Kotlin synthetics have. First, it pollutes the global namespace. So by that I mean like it provides it opens the full project for you to accessing any view, and it doesn't bind to you to particular specific layout. Let's say you have one activity and you are trying to access any view, and it will provide you the IDs for the full project views that you have in your project. So if you have 10 layouts, you can easily accessing any view in any activity. So this is basically having issues that until you hit the production code, until you run your project, and then you find like that ID might be not exist in that current activity or current context, and your app will crash. The second is it doesn't expose any nullability information. So sometimes we, as Android developers or in Android apps, we have a different designs for different screens, and sometimes we have a particular view only available in, let's say, in the portrait configuration, and in the landscape we don't have those views available. And in those kind of scenarios, it doesn't expose any information about if that view is nullable in particular case. So we need to check by our own, like we are managing the nullability of views in different configurations. And the third major drawback I can say, it only works with Kotlin. So most of the time Android developers they are working with the right now is with the Kotlin, but still it's only works with the Kotlin, and Java is not it's not available for Java. So these are the main three drawbacks. Now we have Kotlin 1.4.20, and they announced they deprecate the support for Kotlin synthetics, which is awesome. Some I can say, but if we are having a big projects where we are using the Kotlin synthetics, it's not like a one-time shot that you can use. You can directly, there is no such way that you just hit one button and it will automatically remove the synthetics from your code and just replace it with the other options like I mentioned. You can use the old way like find view by ID or ViewBinding, which is the recommended solution from now onwards. And there are some other third-party libraries like Button Hive that you can use to access the views in your layout from your code base. And the second major change is the package refactoring of the parcelize annotations. So before it was available through the Kotlin Android extension plugins. So as the Kotlin team decided to deprecate that plugin or the synthetic support from this version, so they refactored the parcelize annotations to the new package which is called Kotlin Parcelize. And but this change, if you are using the parcelize annotations already, this change is only to fix the imports and just replace the new plugin with the old plugin with the new one, which is the changes you need to do is in the your module level Gradle files. You should start using the standalone Kotlin Parcelize plugin instead of the old one, which is Android Kotlin extensions. So these are the two major changes, and from the 1.4.2 version. And if it's if your project is super big and you are using synthetics like all over, you might get stuck with the older versions of Kotlin, because you can't use Kotlin 1.4.2 because it doesn't update your if you are having a big project, you might get stuck at some point to update the latest version of Kotlin. But you can start by module, and then you can define your configurations, like in which module you want to use 1.4.2 and go from there. And here are some references that you can use to learn about the migration from synthetics to ViewBinding and Parseable implementation. And also I didn't have one article, I linked that to the slides too. So this is all about the content. Now we will see some code samples and what are the issues with the synthetics and how ViewBinding helps us to resolve those issues in our code base. So let's see what are the issues that we have here. So this is the main activity in our sample code base. And here I'm using the Kotlin synthetics, if you see here. And I'm accessing, it has in the right hand side, I have using I'm showing you the layout. It has one text view field. And let me uncomment this line. So now I'm referencing the TV2. It's a text view, which is in another layout file, which is used in the second activity. But right now in the main activity, I set the content to the activity main, but I didn't get any error that this view is not exist in current hierarchy. So if I run this code, it will crash. So maybe we can try something. So yeah, this is the first major drawback, that you don't get any kind of warnings or any errors when you are accessing the views from your classes in your project. So this is related to the first drawback, which is says like it pollutes the global namespace, because you get access to all the views from your files. As you see, the app starts and right away it crashes, because the TV2 field, it's not exists in the code base. And these kind of crashes can be easily identified. So these are the easily identified issues, because there is no any conditions, and as soon as you run your app, you will see the issues, like the ID doesn't exist. But sometimes, rather than we are directly accessing the layout fields from the different layouts, we might have some kind of conditions. Let's say so in this case, we are incrementing count, and once it hits the number 5, we set the text of that view. And sometimes during the testing, we don't consider these scenarios, or we don't test the conditional flows of our app, and it might went all the way to the production code. And once these scenarios in these scenarios comes into the scene, and then we only figure out like there might be some issues and we are referencing the wrong views in our code base. So these are the first thing for the global namespace. And second is the nullability. It doesn't expose any information related to the nullability. So this is the logo that I have in here in the main activity file, layout file. If you see the design, so I'm referencing to this image view, and I have created a different version of layout for the landscape mode. And in that case, I don't give that image view in here. So in the landscape mode, I only provide the text view. But as you see here, it doesn't give me any issues or any errors like this can be nullable, right? So it, right now I only see the potential null pointer exception because it's missing in some layout variants versions of our design. So it's our responsibility to check to make sure that everything is working fine, or the post or the views are correctly exist when we are trying to access these kind of scenarios. So these are the major issues with the synthetics. And let's see how we can avoid these kind of issues with the new feature, which is view binding, and it's a recommended solution by the Android team. So let me show you the sample code of view binding. I will show you the step-by-step guide how you can implement that. You can use that instead of synthetics from now onwards. So yeah, so this is the new project that I have created, and in here I'm using the view binding. So the first step is we need to enable the binding for view binding in our module level Gradle file. So here I'm enabling the feature under the build features. I'm setting the view binding to true. And if you are just using the view binding, you just need to view binding. Otherwise, if you want to use the data binding, also you can just doing the same thing, providing the data binding field in here and setting that value also to true. So now once you set the value, like once you provide the view binding configuration here, you just sync your project and just build your project. And once your project is done, under the build folder, you can figure out like you can find out the generated binding classes for the relevant classes of your layouts. So all the layouts, they have their own generated data binding classes. So in our case, I have four layout files. One is for fragment and two for activities, and one there is included layout. So here is the first activity main binding. This is the generated class from our layouts. So as you see, it defines all the fields that our layout has. It has root view, and it has one field called included, which is referencing to another generated binding because I'm including the layout. And then we have the text view. So, so this is the sample code here. So you initialize the binding. I created a binding of type like the activity main binding. The name is referencing to the your layout file name. So if you see here, so the name of the layout is activity underscore main. So it just append the binding at the end of the name of the your layout file, and it will be like as I shows you is the main activity main binding. And how you can inflate is this is the way you just call the inflate method on the generated binding class, and from there now you will only have access to the related fields that are only relevant to that binding class, which makes sure that you are not accessing any external views which are not exist in your current activity or in your current layout. So in this case, I have set the text views text, so it's on click listener, and now I don't have access to any other external views from the different layouts. So now I have only access to these three properties which are included only in this layout. So this helps us to say from say from the nullability also, and it doesn't pollute the global namespace because it's only related provides related properties that are only available through that particular binding class. So let's see the code. Next thing that I want to show you is about the nullability, how it automatically handles for us the nullability. So this is the same version of the layout for the landing. For the landscape mode, I don't have image here. I remove the image. And for the portrait mode, I have a layout with the image view here. So now I have two different versions, and let me remove this property here, and let's build our project again. So once the bindings for the different layouts have the different versions of your layout files for the different configurations, like one have image and one doesn't have, you will see the difference in the generated binding classes, like how it automatically handles for us. So now if you see here, before it was like non-null because we have a logo in both files, or I'm not generating binding for one class, I only generating for so now the image view here, it's a nullable because we don't have a logo available in all configurations. So if I now want to do something with this logo here, and if I remove the null check, it will shows me the error. And you see it's automatically the data binding is enough smart, like it finds out that this is not available for all configurations. So I need to, if I need to change its visibility or anything for that particular view which is not available in all the layout versions or all the configurations, I need to access them like in a safer way. So this is how it handles the nullability for us under the hood. And next thing is, there are a few properties that you can use, because sometimes you don't need, if you don't want to generate the view binding classes for your layouts, you can set the property which is called view binding ignore to the parent view of your layout file, and the generated binding classes, they will ignore that layout file to generate the view binding class. So if I set the view binding here to ignore set to true, and as I set it to true, now it's not visible from the binding class because it's only available in that particular configuration which is the default one. So now the logo is not exist anymore for us, and binding will automatically update once you set the property, it will automatically update all the related fields or the views in your generated binding classes. And second, if let's say I don't want to generate view binding for particular view, you simply skip any view within your layout, just removing the ID. So in this case, if I delete the ID for the text view, it will not generate a view binding field for this class, and it will not available anymore. These are the two ways of ignoring generating bindings for our views. And third one is like sometimes we have a common components, like maybe sometimes toolbars or anything related, something like that. So in this case, I added the sample include layout class, which has only one text view called TV2. And to generate to accessing the properties from the included layouts, in the case of the view binding, we need to provide a ID to our include tag. Otherwise, it will not generate view binding for those, and we are not able to access those included layout fields from our code base. So here I provided the ID here included, and if you see the generated binding classes, here it generates the relevant field, which is referring to the included sample layout binding, which is again the generated view binding class for that particular layout. As I told you, like the view binding, it will generate the view binding classes for all the layout files. So now we have included here, and now if you can see in the code base here, it's like binding dot included, which is referencing to the included tag here. And by this, we will able to access the relevant fields from that layout. And in this case, I'm accessing the fields from the included layout here. And the last thing is the parcelize annotations, which are refactored to the new package. And for that, there is some changes that we need to do in our build files. Let me show you that one first. So in your modules, like for the synthetics, we have the old plugin version, which is called Kotlin Android extensions. But as of Kotlin 1.4.20, we have the version called plugin, which is the only relevant to the Parcelize, because the synthetics are no more supported by the Kotlin team. So they have new plugin which is called Kotlin Parcelize, and you need to add that plugin into your build URL file to the relevant module. And before, if you are using the synthetics, the old import is this one, which is from the Kotlin Android parcel, this one. And from now the new plugin, it's from the directly from Kotlin Parcelize. So they totally decouple the dependency between the Android package and the Parcelize one. So they now they provide us directly support for the Parcelize annotations. So I fixed the import. I just remove that import here. We are good to go. And on that the click listener of this button, this text view, I'm moving to the next activity, which is called main activity 2, and I'm passing the parcel here. So if you see the sample code, sample running code, which is synthetics migration. So this is the sample of accessing the parcel. The everything is working as before, but now it's just the plugin and the package refactoring for the Parcelize, which is like right now it's there is a new plugin that I showed you earlier, and now you just need to fix your imports and you're good to go. And for the view binding, this is the new way to go with to accessing your views from your layout files. Or if you don't want to directly removing the synthetics, you kind of stuck to use the old versions of Kotlin, or you can use the find view by ID, which is the I think the oldest way of accessing views. And when we talk about the view bindings, there is one there is a one concern when we talk about the fragments. So in case of fragments, we, as you know, that the life cycle is totally different, because sometimes fragments they are exist after their views are destroyed. So we are using view pages, like one page is not currently attached, or it's attached but not a view is not there exist, like we are moving to the back and forth. So in those kind of scenarios, we need to make sure that we are initializing the binding at correct places, otherwise it will leads to the memory leaks. So how we handle those kind of scenarios in case of fragments? So I initialize the binding, set it to the null here, and on create view we create our binding here and returning the root. So the root is basically the parent tag of your layout file. So it basically returns the parent tag of from by referencing the binding. And what we are doing, or what is the recommended approach, so that we are avoiding the memory leaks in our layouts or in our project. On destroy view, we what we do is we just reinitialize the binding to null, so that it will not holding any references to the views which are not currently active, or not attached to any node node in the active state. So this is the major I think the main concern when we talk about the fragments. Rest is really easy to do, like a migration, just enabling the plugin in your build files, and from there on you have generated binding classes, and you can check the code in your generated binding classes here under the generated folder, which is under your app folder, and you can go all the way from build, and there is a folder called data binding, and it has all the data binding classes. And you can go through the code to get the basic idea, like what actually it's doing here. And yeah, that's all pretty much about the code samples that we have for this one. And yes, the in the slides I have attached all the references that you can go through, which will help you to understand the view binding and how you can migrate. So yep, this is all related to the what are the major impacts of Kotlin 1.4.20 in Android. So thank you everyone. If you have any questions, you can post in the chat. I will happy to answer. I will share the links to the slides and the article that I have written about it, to the view binding in the in the chat section, so you can go through them if you want to read about the view binding migration from synthetics. Yep. So thanks everyone.